Yeah, good morning to all of you. In this lecture, I am going to give you the another example to find out the concept of generalized momenta and corresponding cyclic coordinates. So, we have a Lagrangian. The Lagrangian of a system is given as 1 by 2 I theta dot square plus 1 by 2 m r dot square plus r square theta dot square. So find the generalized momenta conjugate to this r and theta coordinate. So generalized momenta corresponding to this r is pr and theta coordinate is p theta, which means we have to find out the generalized momenta corresponding to this Lagrangian profile where I is moment of inertia. So generalized momenta, the expression of generalized momenta is simply del L upon del Qk dot, which is Pk. Here Qk is r and theta. So we have two generalized coordinates r and theta. So therefore we have to find out the value of generalized momenta corresponding to these two coordinate system. That is these two generalized coordinate r and theta. So for r coordinates, our generalized momenta is simply del L upon del r dot, because our Qk is r, our Qk is theta. So this is PR. Now what is our del L upon del r dot? Del by del r dot, we have 1 by 2 I theta dot square plus 1 by 2 m r dot square plus r square theta dot square. Now differentiating this expression partially with respect to r dot. So this will give 0. Yeah, let me write one more step. Del by del r dot 1 by 2 I theta dot square plus 1 by 2 m del by del r dot square plus r square theta dot square. So this will give 0. This will give something. This is not 0, and this will give again 0, because we are differentiating partially with respect to r dot. So only r dot term give some value and rest will be 0. So this will, so what we have simply 1 by 2 m 2 r dot. So this 2 will cancel out and we have simply m r dot. So del L upon del r dot is simply m r dot, and what is this del L upon del r dot? This is simply PR, and we have to find out generalized momenta conjugate to r and theta. So generalized momenta conjugate to r is PR. So PR is simply del L upon del r dot. This del L upon del r dot, which is m r dot. Now for theta coordinate, so for theta coordinate we have to find out del L upon del theta dot, which is del by del theta dot 1 by 2 I theta dot square plus 1 by 2 m r dot square plus r square theta dot square. Now we have two different expression in theta dot. So corresponding we have some value and rest will be 0. Now differentiating partially with respect to theta dot. So this will give something, this will give 0, again this will give something. So what we have simply 1 by 2 I differentiating theta dot square del by, let me write, see, del by del theta dot square is twice theta, and this will give twice theta. So this will twice theta plus 1 by 2 m r dot square is 0 plus r square twice of theta dot. So the final expression is I theta dot plus m r square theta dot, which is del L upon del theta dot. So generalized momenta conjugate to theta, generalized momenta conjugate to theta is p theta. So p theta is del L upon del theta dot, which is I theta dot plus m r square theta dot, and what is our PR, which is del L upon del r dot, which is m r.